So in my last video, I described what Simpson's rule was all about for using parabolas to estimate the area under a curve. And the rule basically went like this. We said that if we wanted to approximate an integral, a definite integral over some interval from a to b, the way that we would do it is that we would say that our rule told us that we would approximate it by using b minus a over n, but we take 1/3 of that, b minus a over n being our delta x, times our summation, which would be f of x of 0, plus 4 f of x of 1, plus 2 f of x sub 2, and then we're going to start alternating between 2's and 4's. So we would have 4 times f of x of 3, 2 f of x of 4, 4 f of x of 5, and so on down the list until we got down to the end right here, and we would have 4 f of x of n minus 1, the second to last uh, rectangle area, and then of course f of x of n as our last point right there. So if we're going to stick with that pattern right here, the easiest way to do it in my mind is to go ahead and use a table. I made a little table for myself and I said, well, let's figure out what's got to happen here. All right, on the interval from 0 to 4, right? Maybe a good way to think about it is on a number line right here. And we're starting at 0 and we're ending at 4, and we have 8 divisions. Well, it would be easy if we had 4 divisions, right? Because if we had 4 divisions, we would say 0, 1, 2, 3, and 4. But we've got 8 divisions right here, so what does that mean? Well, each of those divisions go by halves, right? Because we have 8 halves, that gives us 4. So if we think about it that way, it just makes it a little bit easier to divide up here and get our x values that are going to go into our expression, 7 halves being the last fraction right here. So for each of these n values right here, we're going to be finding the f of x value at 0, 1 half, then 1, then 3 halves, then 2, then 5 halves, then 3, then 7 halves. Boy, that was a poorly executed half if I've ever seen one. 7 halves, thank you, pen. 4 right here. Right now, of course, you still want to figure out delta x, right? And we could stay very easily. It's 4 minus 0 over 8. So that means 1 half when we reduce. That's where we're getting each of these values fixed along the line. All right, now we're going to evaluate f of x of n, and that means that we're going to take our chances with numbers like, well, the square root of 0 squared plus 1. It gets worse as we get larger fractions right here. This one's the easiest, of course. I've gone through and I worked these out again for you, and you can verify that if I take the square root of 1 half squared plus 1, I get the square root of 5 over 2. And just working my way down the list, when x is equal to 1, of course, I get the square root of 2. When x is equal to 3 halves, I found the square root of 13 divided by 2. At 2, I found the square root of 5. At 5 halves, I found the square root of 26 divided by 2. At 3, I found the square root of 10. At 7 halves, I found the square root of 51 divided by 2. And then at x equals 4, I found the square root of 17. Now, of course, this doesn't look like a lot of fun because we do have a lot of squares going on right here. But remember, we're multiplying by these multipliers in our rule 1, 4, 2, 4, 2, 4, 2, and so on down the list to 1 right here. So if we take these one by one, of course, our values look like 1 square 2 times the square root of 5, pardon me, 2 times the square root of 2, 2 times the square root of 13, 2 times the square root of 5, 2 times the square root of 26, kind of interesting it's turning out this way, 2 times the square root of 10, and 2 times the square root of 51, and then finally the square root of 17. Now, of course, I'm not going to write out a sum that contains all these radicals because, well, it's kind of hard to figure out. So what I'm going to do is I'm just going to go ahead and give you the decimals that I found on this one. And as if by magic, all of my values appear. And so when I take that sum and I add these all up, remember that what I'm going to do is I'm going to take, by my formula right here, b minus a over n. So in other words, I'm going to take 4 minus 0 divided by 3 times 8 times this sum to get my value, which is to say I take a 1/6 of my sum, which is to say 1/6 of 54.9123. And by doing some appropriate mathematics here, of course, we end up with 7.9011 as the approximate value of our integral from 0 to 4 of the square root of x squared plus 1 dx. So the process is pretty straightforward. A table helps to facilitate adding all of these things up if you just have a nice limited number of areas to deal with right here. And a little bit of programming, if you had Excel skills, could do this as well. In any case, good luck with your assignment, and I'll see you next time.